Alright, we have this question to solve which says exponential x minus exponential minus x all divided by 2 equals to 1. Alright, we can visualize this side of the equation to be 1 all over 1. So in that case, we can cross multiply to have that 1 multiplied everything here. We have exponential x minus exponential minus x equals 2 multiplying 1 becomes 2. Next we can do is we can move this 2 to this side of the equation to have exponential x minus exponential minus x minus 2 equals 0. Now in indices, we know that a negative index denotes a fraction. So in that case, we can rewrite this as 1 over e exponential x, so that the equation becomes equal to e x minus 1 all over e x minus 2 equals 0. Going forward, we can set to let p equals ex, since we have es common to this and this, so that this equation now becomes p minus 1 over p minus 2 equals 0. Now to eliminate this fraction, we can multiply through by p, so that we have p multiplying p, we have p squared minus 1 over p multiplying p, that would be 1 over p times p. We're left with 1. So we have it to be p squared minus 1 minus 2 multiplying p, that is 2p. And of course, 0 multiplying p will still remain 0. So we now have a quadratic equation which we can write as p squared minus 2p minus 1 equals 0. Now going forward, let's compare this with a x squared plus bx plus c equals 0. In doing that, we discover that the coefficient of the first term here, there's an invisible one here. In that case, our a here becomes equals to 1. Our b here is this minus 2, so b is minus 2. And of course, our c is minus 1, so c is minus 1. So solving this quadratically, we apply the quadratic formula which says that for this expression, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. And of course, our x here is equivalent to our p here, so we can write this as also p equals this, so that our p now becomes equal to minus into, since our b is minus 2, plus or minus square root of b squared implies minus 2 all squared minus 4. Our a is 1, So 4 times 1 times our C is minus, our C is minus 1. So into minus 1, close brackets, all divided by 2 multiplying by 1, which is our A. Simplifying, we have that P equals minus 1 times minus 2 is 2, plus or minus. Simplifying this, we have minus 2 all squared is minus 2 times minus 2, which will automatically be plus 4. So we are having this side to be 4 plus minus 2 squared is, minus 4 times 1 is minus 4, multiplied by minus 1 again, we have it to be plus 4. So plus 4 all over 2 rest, which we can write as equals 2 plus or minus root 8 all over 2. And of course, root 8 is something else, 2 root 2. Okay, let's find out how it is like that. Root 8 is something else, root 4 times root 2. And of course, root 4 is 2, so this will give us 2 root 2. So that we now have this side as equals 2 plus or minus 2 root 2 divided by 2. And of course, we can write this as P equals 2 into, since 2 is common between here and here, so 2 into 1 plus or minus root 2 all divided by 2, so that 2 can cancel 2 and we are left with P equals 1 plus or minus root 2. So that case P assumes two values of P assumes two values of P equals 1 plus root 2 or 1 minus root 2. So that case P equals 1 plus root 2 or, now since 1 is less than minus 2, so in that case this particular one is going to be the whole of this will automatically give us a value less than 0, and of course it is invalid. How is it invalid? It's invalid because for real numbers e to power exponential x cannot be less than 0. Yes, if x must be a real number. So in that case, we are taking this as our only solution. Let's clean this up. So we are taking this as our only solution. But let's recall that from this place P equals exponential x. So in that case, exponential x equals 1 plus root 2. But we're looking for the value of x, so we have to take the natural logarithm of both sides. So we have ln in x equals ln into bracket 1 plus root 2. So that's this e we cancel ln. We are left with x equals ln into bracket 1 plus root 2 as our final answer. All right, thank you.